It is down. I can't run shaders when it's down. Unreal. Yeah, gateway timeout. It's like the wiki, right? So you just got to stare at my ugly mug instead of a nice shader while the coffee goes. Sounds like the coffee's done. Uh-oh. The garbage. Not my garbage. Quaternions needs to take out the trash revealed. It's a stirring spoon. Usually this part of the stream is hidden by the shader. First 2 minutes making coffee. That is a lot of cream. This is going to be a very creamy coffee. I am out of sugar as well. Get the dust off my headphones. I dusted off my computer. I switched my graphics cards back. Oh yeah, why don't I set that up? So, Olama. If we look at NVIDIA SMI, you can see there is 2 GPUs. Usually I have one on a stub driver. So I can use it with VFIO. But, let's see. Olama list. Serve. Olama list. Alright, remove DeepSeek. We don't need any DeepSeek anymore. This serious delete 70 gigabytes. Alright, what's the new cool people model? It's this one, right? Reasoning model, compared to DeepSeek. So this is the full DeepSeek model, and this tiny one sometimes even outperforms it. So cool. Can I just uh 19 gigabytes. That is definitely easy to type. That is definitely creamed up coffee. DeepSeek. It's downloading at 117 megabytes per second. That's crazy. Did I successfully clear my drive? Free space, 130 gigabytes. It should have freed like 60 gigabytes. Where is it downloading to? Olama download location. Linux. No way. Ew. P locate. I don't think it's in Snap. User share. It's just using home. Oh, okay. So it'll be like yeah, okay. Models. No way. Ooh, okay. So it presumably did. Oh, I think I had 80 gigabytes free before, so I think it makes sense. It is nice having fast internet. DeepSeek. So we'll see both GPUs load up with the model. And hopefully it's like smarter and less censored, you know? Well, I guess I should continue my effort from yesterday to mess with the physics. Verifying. Success. All right, is it doing it? Oh, yeah. Okay, the user said, "What up, gamer?" I needed to respond in a friendly, casual way. Come on, you can do this. Start with a greeting. It's thinking, grinding for those wins. Holy. Let me check if that's the right tone. Yeah, that sounds good. Let's go, gamers. Gross. Recovering from sickness. I feel way less sick now. Still got that nose junk, though. And the deep, sick voice. The current strongest model that fits on a single GPU. This is a Google one. Chatbot Arena Elo score. What? And I'll do it versus the QWQ model. Where's DeepSeek? So this one is less good than this one, according to these charts. No way. Ugh. All right. Let's try the same prompt. Let's find my YouTube video and try the same prompt and see what it does. Let's get rusty. No way. Hey, it's me. Professional web dev. All right, what was my exact query? Actually, you know, I might be able to copy it out of history. Come on, come on, come on. Yeah, all right. Exact same. This is so cool. The idea of running AI on my own computer is really cool. Like when it's running somewhere else on the cloud, like it's just kind of useful, but now it's cool and potentially useful. It hasn't really, the DeepSeek one wasn't really that useful. All right, well, we'll see. Yeah. I'll just do this just in case, and then. So apparently Zed has Git now. Ooh, it's a button. Oof. There's no changes to commit. Control Shift G. They said in their blog stuff that you could always navigate with the keyboard, which is really cool. That's cool. I think I need to not get distracted by other things. So I was thinking about like, oh, what if I fix the unions on the Roblox loader? But that's easy. I'm here to solve the hard problems, which is the physics. Right. So I observed this thing being wrong. I directly observed it. The face n itself is 0. Okay, so that means the edge faces is bugged. Oh, that sounds like it's done. Wow, that looks a lot like the other one. Honestly, let's see what the diff is. Oh, that one. It looks like really similar. Yeah. Max width. At media. What does at media mean? Responsive design. All right, let's see what it looks like. So how I do this is I go here, no, not strafe maps, and then landing page. And then we can do Python, HTTP server, and then localhost, 80, 8,000. Oh, wait. All right, so if I make the logo stuff works, assets, logo, and then assets, BG. Hey, that looks very similar to the one that the other AI did. Well, that's pretty cool. So the other thing, Claude AI, that one, was not running on my computer. That's what that was my point. Why did it take me so long to think about that? This is actually what the video looks like behind the blur on the ShadeToy website. It actually is 360p, but you can't tell because it's all blurred. Cool. Cool. Click to open website. Damn. That's fun. Okay. Physics. Bug. Ah. You're done. You're done. You can keep going. Deep. Okay. Ooh. Reviewing the applications, I recognize every single name. You gotta be a aged community member to be a moderator, it seems. We need you on the team. Hopefully the website and stuff can like make a better experience for people playing the game. Okay, so I was right here. Oh, go away. And then I went, oh, inline. Silly me. Inline means you can use it across modules. So it's totally unnecessary here. cow. Oh. I see. It's the monomorphized. Should I rebase? I'm gonna bop first. Rebase. Yeah. Fair. So we can say copy. Sec. Alright, that was the only problem. Oh, yeah. So now what? Let's run it. Strafe, it. Cargo build. No. Run. Release. Bug 2. Get her done. There's vinegar news. Cool. Roblox sober is now unavailable. Very poggers. That's the physics bug. Leaked. Finally, work is paying off. I guess it's still not yet. We still got roadblocks before the website is up. Oh my god. Okay, so it's edge faces is busted. Nah. It's the Minkowski, right? What happened to that debug? Who did this? Face crawler. Edge vert. Minkowski edge vert. Oh, it's here. Oh, okay. So it's returning an edge. That's parallel. These two edges are parallel, is what is going on. Edge 0 is a parallel. It's exciting. I'm excited for the website. There's so much we can do. How do I debug this? Edge face. So, okay, think. If the normal vector is not coplanar with the face, then it cannot be parallel to the edge. I need a little snack. Oh, that's gross. I'm gonna activate the vacuum for a second. Oh, that didn't work. That was a disgusting amount of dust. Yeah, I'm gonna get a snack. soup. All right, what are you thinking? Soup. Soup choice. How do I? Oh my gosh, it's so hard to like put them on the camera while looking at it mirrored. Cover up my face. Clam chowder or chicken a la king? Choose wisely. I don't know. It's not that important. uh, soup. Soup. Think soup. Hear the soup. Taste the soup. I'm not gonna do that. Eeny, meeny, miny, mo. Catch a tiger by the toe. Every holler, let him go. Eeny, meeny, miny. Chicken a la king. I already had that one. I'm gonna have this one. Okay. Open the cans. I got cans. All right. I'm gonna have clam chowder. 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 Exciting website exciting. How long have you rocked the beard? Ever since it started growing. I'm not a big beard trimmer, so whatever happens on my face just kind of stays that way. I try not to like let it get out of hand. 10 plus years. No, this is like a month or two. Like less than a month since I trimmed it. I can grow like a insane beard. I am blessed with facial hair. Or cursed, depending on how you look at it. Blessed because you're not balding. True. That is pretty blessed. Why didn't it just load the page directly? Like it was there. Go. Did I? Yeah, it's right here. Soup. Yes. Big spoon. When are we getting strafe client localization? That will probably be a community feature. So currently, there isn't any text, so localization is not required. So yeah, that's benefits of having no UI system. Uh, solely number-based game. Yeah. There's no strings except for the title. The title of the game. There is strings in the like dependencies. Notably for loading Roblox maps and loading CSS maps. Those are like interpreting strings all over the place to convert them to the numbers only system. Well, it's data structures, really, not numbers. It doesn't go together very well. I think I might leave it and then have it after. I'm gonna get a drink. Yes. Have you made anything cool lately? Jeans? Who doesn't wear jeans? Jeans is more like pants. The pants. Add knives. Wouldn't I love to do that? Algorithmic programming competition. Really? That's freaking awesome. What the hell? That totally counts as you did something cool. Potato. As ref. I think this makes sense. Because it's just it's some kind of data that I can construct a reference from. So it might be owned or it might already be a reference, but I can for sure construct a reference. And then this can be into iterator just fine. Whereas before I had deref, which like just happens to be similar. I think this is more accurate. You know what? Let's learn about the Chinese government. I think that's funny. Is there any reason to be critical of the Chinese government? XDD. Wait. It didn't think? Hold up. Wait a second. The legacy of slavery. Oof. XD. So, okay, I'm gonna duplicate this because I'm using it for debugging. So when I run this, this is my unit test. It's nice to have a visual. I think I'll bring up the visual. Strafe, tools, run. What map is that? Arcane V2. We want Monster Jam. So on this map, there is a part right over here. Wait, can you see this? You can't see this. You couldn't see it that whole time. Nice. So this part right here is specifically goofy. So if I come at it like this, I can like touch it, right? And it like kind of works, kind of. But then if I fall straight down, if I'm hovering just above it and I just fall straight down, I go through it consistently. And that's the important part, is that it's a consistent physics failure. So I set up a test case that's exactly doing that. So in the code, it look like this. It look like this. So physics bug 2. It's called physics bug 2 because over here on the issues, it's this bug. So what does the code look like? Okay, so it loads bhub monster jam, and then it loads the map into the physics data, and then it creates a new physics state at the exact position hovering above the thing, and then it idles the physics for 500 milliseconds, which allows it to fall through the object. So that's one physics request, I guess. And then this is the outcome of that. So it loads the file, generates models, blah, 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 simulate. And then this is a print statement that fires when it tries to, when it tests a model for physics. Like it's running a physics calculation to see if you're going to hit it. That's what that means. And then this is the inner workings of the physics algorithm. So there's two steps. There's setup, where the physics algorithm is calculating what's the closest point on the object to what's the closest point. So it's just setting up the closest point because it needs that to then run the rest of the physics algorithm. And I think this is right. And then this is the crawl. The algorithm is called face crawler. And as you move along the curve you're tracing out that may or may not hit the object, it tracks the closest point on the surface. So if you have like this, it would like go along the surface and crawl. It would crawl the faces, right? It's the face crawler algorithm until the 2 points intersect. And that's how it determines physics intersection calculations. That's how it does it. That's how it works. And so next transition is we're transitioning from a face to an edge, or an edge to a vertex. Because like if you go over this corner, then this will be the closest point for a while as you move along the curve, and then it'll keep going. So fev means face, edge, or vertex. It can be any of those three. And so you transition to a fev. You always are somewhere on the object. And it's tracking the closest point. This looks fine. It's like, yeah, I'm trying to get the next transition. And it goes like, it's testing this edge. This edge looks fine. These are huge numbers, but like that's normal for how I wrote it. And there's a face vert. That's a Minkowski face, which is, I'm not going to explain that right now. I've explained it many times before. It consists of a face and a vert. It's a face vert. And the normal vector is this, and the normal vector is that. I don't remember what these actually mean, but those are numbers, right? There are some numbers. And then this one says edge, edge, and that's valid as well. But then the numbers are 0. And I looked at the exact numbers, and they're actually exactly 0. And I think that's a bug. So I think that this is the bug. And I've located the bug, and I can evince it at any moment. I can activate it. I can make it happen. So how does it get these numbers? Well, that is right here. So it goes like, what are the faces of this edge? No. This is something else. No, that's it. Right, because an edge is a face. So this is from a face. So it's returning a face that doesn't make sense. So probably this code is good, but this code is bad. And this code exists right here. So we are actually exactly in this case. It says edge vert, and that's the edge vert case. So some part of this is wrong. Somewhere, somehow, something is wrong. Why don't we just print everything? Like, just do it. Just go for it. Oh, this is gonna be okay. That's gonna be like that. Come on. Yes. Okay. Vertex edges. Okay, print The D value. What's the D value? What's the Wi-Fi password? So we don't super care about DD. We do care. I guess I'll just leave it. All right. Run it again. Do it again. D value is equal to 0. So it's like checking these things out and none of them work. And then DD, boom, it does work. Except I'm confused now. Okay, all right, let's like print the sections here. Can this print? Ooh. Cool. Okay. So it's like I'm and then that's great. Yeah, I think I need to run it again. It's too confusing. Okay, so this is one big old calculation. Okay, so that was the confusing part. Okay, so what happens? So we end up with edge 0 and edge 1 are collinear. They're just pointing in the same or opposite direction. They're just some multiple that may be positive or negative of each other. They're collinear. And that's bad because when you take the cross product, you get 0, and it's kind of meaningless to work with in the physics and causes bugs. So how does that happen? So if this value, okay, so but I should look like right above it. So D is negative 0. Is this a rounding problem? So negative 0. Let's do a full debug print. Where's the debug? How many bitty bits is it? This is dumb. It's actually insane that this runs in real time. Like, it's dealing with numbers like this, and it's multiplying them together. That's how the physics runs. Okay, so it looks like it's a really small number, but how does it end up being exactly 0? Edge face 0n. What does that mean? I don't actually know the exact topology of the object. I know it's got a bunch of like clipping planes, but could the mesh have been generated incorrectly? I saw it. It didn't look like it was generated incorrectly. Oh my god, bro. Oh. Bro, let me out, bro. Oh, yeah, there's no graphics. So, like, if we look at the bottom here, it's all like, the geometry is very crazy with respect to, like, Roblox objects, but it still constitutes a convex shape, and the physics algorithms are designed to work on any convex shape. So the fact that it doesn't work is still a bug. Oh, did I? Hmm. The bug. The bug. What happens to the bitrate when I go like this? Oh yeah, no, it shoots up. That's 380 megabits. Makes sense. Does it? So it looks like it's a very small number. What just happened? Where am I? Did I just enter the void? Like what? Okay, we're back. Ah, god damn it. Can I compress it? Think, think, think. Think, think, think. Yeah. Let's see. Sure. Let's try compressing it. I'm gonna try compressing it. It's a distraction, but whatever. Go. Come on. Tiny, tiny, tiny. I don't think it's gonna be tiny. Oh, maybe it is gonna be tiny. Ooh. I arrive and it turns into a debugging chat. The moderators were discussing things because there were some new moderators were just chosen, and then I accidentally typed in the chat because my mouse focuses whatever window it hovers over, and I tried to move in the strafe client, but I was hovered on the window, so I typed. And they were making fun of me. The beast has awoken. Everybody hide. Now, what do you suppose that means? Shave unibrow. It's kind of part of my face. It grows back after about a week. I'm not about that maintenance. Soup vanquished. Now I heat up the coffee, and we keep going with the coffee. Ugh. So I saw a small number. That's a small number, believe it or not. It calculates to this. This is represented in decimal. I think that has something to do with it. Okay, so is it because the faces are rounded? So what does that mean? So you have to make a choice when you have meshes, and you're trying to use fixed point arithmetic. Either you specify the mesh vertices exactly, and then the faces are derived and like more precise, because like a face is defined by like 3 points, and like that can the normal vector of that face can be pretty wild. It's 3 times more precise than the vertex positions. Or you can define the faces, and then the vertex positions are precise because you like do a determinant, and it's linear algebra to find the point of intersection of 3 faces, and then that is 3 times more precise than the face normals. But I do neither. I have imprecise vertices and imprecise faces. I just drop the extra precision. That could be it. It could be a precision issue where the faces don't exactly match the vertices. So it thinks that it's slightly negative. That could totally be it. Honestly, the best solution is probably to make inaccurate faces. And like or inaccurate vertices, I guess, and then derive so that the precision triplication, tripling the precision, ends up with 64 bits. What's 64 divided by 3? It doesn't actually divide by 3. So it'll be like 63 divided by 3. It's like 21 bits for the vertices. So that would be during generation. Why don't I go look at that code? So let's look for fix underscore. Ooh, what about here? Okay, that's expanding. Expanding. You know what? Yeah, look. Face, push, intersection, divide, fix one. What the hell does that mean? So that means that it is calculating the vertices, and it is truncating the precision. So then when it goes back and calculates that would necessarily have that problem, wouldn't it? This might actually be the bug. This is really subtle. I think I want to be distracted and write more math. So I'm not going to actually fix the bug. I'm going to improve the tools with which I can fix the bug. And there's something somewhere. Who did this? What was it called? Did I ever have another origin? No. All right, I'm going to add fixed wide, and the URL is here. Remote URL. All right, so now if I fetch, we can see all of the crazy branches. Truncate. It's got to be near the top. I'm going to go to the top. Oh, never mind. Why is there... Oh, there it is. Okay. Okay, so there's that. To float push solve. Oh, it's so cool that it's interlaced with the other comments. Binted fix. Truncate assert. Is that... Where's my truncate stuff? Was it already merged when I wrote that? Oh, hell no. What is that? Bint. I swear to God, I have this code somewhere. I was trying to find it now. From float to. I don't think that's it. No, that's not it. No traits. Where's my work in progress, man? Oh. Is it on my local version? It might be there. Okay. Oh, it's not here. Yeah, that's not gonna help. I have to open it in this. There it is. No, that's not it. Fix 1 equals 2. Oh, hell no. With convert. There it is. It's with convert. So this is not gonna fly. I wrote this and I liked it. And then I didn't add it because I had just merged the whole feature, and I was like trying to let it stabilize, but now it works very well, and this is improve. This is an extended idea. So I'm gonna go like this, and then over here we can fetch. It's called width convert. And there is no chance that this is gonna rebase, but that's okay. Oh, it just perfectly rebased. What? I didn't expect that in 1,000 years. Apparently I haven't touched this code. Damn. Oh my goodness gravy. Okay, so this breaks everything, but that's the point, is that I have to be more precise with my language. So this means that none of this works. Oh, this doesn't even compile. Oof. N. Square root truncate should be the way, right? So there's wrap clamp. Wrap is truncate. Holy. I can't believe this works. Using wrap because square root always halves the number of digits. Clamp would be more correct, but more safe. It's like defensive, but is slower. Surely. All right, now we can see all of the other errors. Whew, okay, common doesn't compile because making the sense. Okay, let's F for fix. Yeah, this is clamp. Silent. It should probably be try from. I don't know, man. All right, this doesn't exist. Yeah, fix. What is this? From ratio for time. Do I have a trait? This is sick. Trait clamp. Let's go. Clamp. It's a generic. Oh, yeah, that makes sense. All right, let's go for clamp. I might need more. Precision. Does that make sense? Clamp. Mm-hmm. I think it's the most correct. It's a little bit slower. Okay, what is this? Test angle. Divide fix. It should be rep, I think. Because it's sine cos. From rotation for matrix 3. Okay, so it's sine cos. So we should be able to wrap here. Just because it's faster. See, I have to decide every time whether to clamp or wrap. There's a third option. I don't remember what it is. Let's see. Narrow. Oh, I see. Okay, so narrow is wrap with error. I see. This is genius. Oh my god. Wrap, try into clamp, try into. Wow. Wait a minute. Clamp. Impl fixed. How do these not conflict? Because it's saying this is clamp underscore. And it calls narrow, and it also calls clamp. But then clamp also calls clamp? Huh? Okay, so clamp calls narrow, and it also calls clamp. And then clamp calls clamp. Okay, this is clamp for the result type. Okay, that is a breadcrumb trail of functions. It's brilliant. Okay, keep going, keep going. There's errors. We got errors to fix. Okay, transform point is fixed 2. So this is widen. Widen can never fail. Oh no. Just getting started. Okay, I should save my work. This is fun. I'm having fun again. Boom! Making my math better. God, I can't believe this patch rebased for free. Does it pass tests? I guess I can just go here. Why is it compiling common? Okay. Clamp. Passes tests. Okay, what is this? Gravity times time divide fix one. I think that should be clamp. I think most of them should be clamp, but still. So square root wrap is faster. Wait, it's already that size. Is this a widen operation? 1, 1, yes. You see, all of these fixes become clamp, wrap, widen. It's all. It's not. There's nuance. This is 1.1. So this is a 2. So this is a widen operation. And then this is a clamp. Uh-oh. Widen 2 is not available. Oh. Radicand. Okay, this is 4. Why does it think that's 1? Okay. That's crazy. Okay, this is clamp. Gravity dot length. Wrap should work here. Divide clamp. Whenever you divide, you want to clamp, because you can like divide by nearly 0, and then it just like goes to nearly the maximum. It's a number that's very high. Square root length times height. Square root wrap should work here, because we just got square root. Here's another clamp. So last time I went through this, I added all these fixes, and I wrote this feature right after I did that. So I was like unsure if all the fixes would like work, but it stuck. I kept it, even though it was a bit laggy. Jump speed. What? Delta AV. Okay, this is a widen operation. Map fixes? No. I had this one trait called fix that would change the fixed point of fixed point numbers. It would perform widening operations to extend the number of bits. it would perform truncation operations to narrow the number of bits, and it would perform, it would not do clamping, where you want to take numbers that are too big and make them the maximum number, instead of wrapping around and having a nonsense number. So I had code to handle this precisely, but I had just added the imprecise way of doing it, and so I was not sure I would keep it. So I didn't want to go and put in the work of doing this. But it's been a long time, 7 months since I did it. So now I'm confident. Okay, so length, with length, that is a 1. So with length, that's a fixed 2. JS, jump speed widen to, oh, okay, it just widens. Dot product minus J with length. I think that can go wrap. Wrap is faster, but doesn't make sense if you actually exceed the range, whereas clamp has a sensible output if you exceed the range, and then narrow is clamp but without the clamping. It gives you an error if it's outside the range. You can like attempt to narrow the range and then return an error, but like my function signatures don't have errors here, so yeah. Might be a source of bugs in the future, but I can always make it better. All right, so this is a widen operation, and I determined that these can be wrap. Jump speed, widen, wrap. With length, wrap. Let's see, jump speed. Yeah. So it has the length of a 1. So it should always fit in a 1. MV widen. Oof. And then limit widen. And then map or Excel limit widen MV minus D. So it should be in range because it was originally 1 fixed point. Or, oh, hold up. D, min. Oh, it's min. And it's a bigger number. D is smaller than MV. MV was a fixed point. So if D is bigger, then that's by N. What if D is negative? MV minus D. So what if your velocity is negative 3 trillion? Probably not a very common case, I would say. But you would, it would limit it to the limit value, which is a fixed point. So it still works, except it doesn't. Plus Excel limit, control dir times Excel limit. And I'm clamping the full thing? No, I'm only clamping... okay. Okay, so your velocity... Okay, so it doesn't make sense. Okay, so it's just a... It's not really a concern. All right, this... What is this? Times magnitude. Like this number... This is a clamp. This is a classic clamp. What is this? Length. Okay, that is a fixed one, so this should be able to wrap. This is a clamp. Gravity times friction. Uh-oh. Okay, this looks like a multiply divide. Yeah, so this should be a clamp because it might go crazy. We don't know. Length wrap will work here because it's just a square root, and that's a 1 already. 4. So this looks like a widening operation. Is that not already 4? NNMM. Oh. I see. So this is actually a clamp. Okay, I think this is also a clamp. This is also a clamp. Very careful. Oh. Well, that's a nice surprise. Look at my amazing code. So it just said you can't clamp a width 2 into a width 4 because that's a widening operation. Clamp doesn't exist. So this should actually be widened. Semantics. Whereas before it's just like, fix it. Now it's precise. Precision talk. Ing. Oh, excuse me. This is definitely a clamp. Because, like, who knows what's going on here. It might be dividing by nearly 0 or literally 0. It's not supposed to, but... Well, yeah, it checks right here, I guess. Oof. This is going smoothly. Uh-oh. Times valve scale. Should I bother with const right now? Oh god. Gross. Okay. Never mind. Okay, this is a I mean, clamp is more correct. It just doesn't matter because it's only going to call it once. Actually, we could do narrow and unwrap. Oh. Oh. Yeah, never mind. Screw it. So these, I should be able to just throw clamp in here because it's the most correct for these like operations that are not supposed to overflow. So the clamp like clamps any overflows. Really, I should be doing narrow unwrap, so it's a bug if it's actually overflowing. But that was cringe. Let's see. Guess that makes sense. Yeah. Map unwrap. Maybe it's fine. Maybe I just go in and call it that. So if I go to linear ops and the vector definitions, I can define. Do I have result here at all? That is the only result. So basically, it's going to be a compound type impl. Vector t copy. Default display. I'll poke it right here. Okay, so this is vector result te te out. Is map const doesn't implement debug. That's so true. Interesting. No destructor at compile times. That's just being cringe with that, but that's okay. Okay, so now I can unwrap a vector of results. What about control flow? Can I implement that? Question mark, a vector of results. Okay. You know what? This is a job for AI. How do I implement control flow on my own custom type in Rust? AI. 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 I'll be right back. Ugh. Next method? What? That's an iterator. That is not control flow. Well, I guess it is, but okay, you're thinking wrong. Like using the to make the question mark operator usable like the result type. All right. While I was thinking about that, allow unwrapping vector of results. Verter. Inline always. How about inline if it makes sense? So then going back to this at the bottom, I don't actually want clamp behavior here. I want narrow unwrap. If it fails, that should be a bug. Instead of like silently not being a bug. Honestly, I might want to change all my clamps to this. Or like I'll look through them. Yeah, there's another one. Okay, so is that... I don't think that really matters that much. It's a jump impulse. It's like runtime stuff. Yeah. Acceleration. Excel. So when you're calculating a style, that's like pretty static. I could actually make it outright static with patience. Yeah, okay, these clamps do make sense. It makes sense to do clamp at runtime and just like silently fail. All right. Okay, these clamps make sense. Use narrow unwrap instead of clamp. Okay, and then next error. Fix one. Oof. Okay, so this is obviously widen. Honestly, can I just fix this outright? This is dumb. Yo, actually I could do, oh, comp ratio. No, this is LT ratio. God damn it. Okay, so I could totally make this a function on fixed point types. But then it's a function on fixed point types. Oh, there is no feature. I see. It's not that important. All right, so this is the bug, if I'm not mistaken. So this is a fixed 3, I believe. Intersection is a fixed 3. But then it's also a fixed 3 denominator. Yeah, no, that's a nasty number. So really this should be narrow and then question mark. So this can go wrong. You can have two faces that are like really close to being parallel, but they're not. And then the intersection point is outside the range of fixed point integers. That's bad. So how do I make that apparent? Oh my god, bro. Okay, so infinite loop 1. Find new intersection. So it'd be like right here. Narrow error. Oh, it's not a direct dependency. Ask Grok. I'm already asking QWQ. Wait, actually in Rust, this is totally DeepSeek. It's been thinking. Bro's thinking. Oh my god, bro. I want to make it better, but this doesn't exist. I don't have it as a direct dependency. What do I do? Export it. So what are the exports here? Pub use. Clamp. Damn. What does that constitute? Should I have everything from here? Probably. Probably I should just have a prelude like this. So, what I needed was narrow error. And then this one, this is a vector of results. But I would like it to be a result of a vector. I don't know if this could make sense. But yeah, I think that this is actually the origin of the bug. It's because the vertex position is calculated from the face normals, but then it's rounded. Are you winning, son? What is this doing? In conclusion, implement the try trait, which is unstable. Oh. You literally can't. Okay. I think I looked at this before and found the same thing, and I forgot. Try trait V2. So still working on it. Hello. It's thinking. Okay, so I can't do this. This is not a solution that is possible. How do you know where to start? How do you just start? So you don't get that ability for a long time. The blank page problem is a serious problem that's very difficult to overcome. In my opinion, the best way to start programming is to find an example, a piece of example code that works and is like kind of close to what you want to make, and then edit it. Make little edits, predict what your edit is going to do, and then observe the result. And you can learn about the code and keep evolving it over time. And you don't have to start from a blank page. Another way to do it is to use AI to not have a blank page, but using AI too heavily can impact your critical thinking skills, which is very important for programming. So starting from a working example is the way. I actually started this project from a working example, and that example, oh, shadertoy is back up. That example is this, 404. This is what my game looked like day one. Still feels like I know nothing. That will never go away. There's things that I know nothing about. There is so many areas of specialization in programming. Like I wouldn't be able to do Linux kernel programming without like working away at it for a year and like leveling up my skill to be able to like do anything, right? I know nothing in that area. But I recently learned graphics programming, or like making my own game engine. Oh, what happened? Physics bug 2. Huh? That was weird. Yeah, so this is my game engine. Think I'm crazy. Programming is just very hard. And there's an infinite amount. There's not an infinite amount. There's many areas of specialization. There's a finite but large amount of areas of specialization. Game development is very multidisciplinary. There's you need a lot of knowledge to do something like this, make a game engine from scratch. And I have like 16 years of programming experience, and I've tried to start doing this every couple of years for the past 16 years, and I only was able to break in about a year ago and start doing what I really want to do. I know syntax. Syntax is only about 30% of learning a programming language. 70% of learning a programming language is learning programming. So that does mean that you can learn new programming languages relatively easily. After you pick up one or two, picking up 3 or 4 or 5 or 6 is not very hard. So yeah, programming is the hard part. Programming is thinking. Programming isn't typing on a keyboard. Oh my God. So what I'm trying to fix right now is physics bugs. So watch this. If I walk, I just fall through the ground. There's a bunch of like random physics bugs like that. Yeah. So yeah, I think that the best way to learn is starting from a working example and iterating. And that's a great way to just program in general as well, is instead of just trying to make it perfect from the beginning, oh my goodness, make something that does something, and then you can look at it and go, okay, well, actually, I can make it work better if I did this. And that's so much easier than making a perfect thing from nothing. Just learn Python. That's a good place to start. I am writing this in Rust. Rust has a lot of well thought out paradigms where using like 60 years of programming experience, they went, this time we're going to do it the right way. But that also means, like, if you haven't experienced the rough edges of using nasty programming languages, you won't necessarily appreciate how nice it is to use Rust. So like, you could learn Rust as like your first programming language, but maybe you wouldn't like it. I don't know. It's not for everybody. It's not for every problem. It doesn't have to be the solution to everything. I would like it to be the solution to everything. I would like to solve every problem with the Rust programming language. I really like it, but there are other tools that can get the job done. Web is playful. I've never done web. That's another thing that I don't know anything about. So people say that web programming is very easy, but I just don't know anything about it. Oh, does this? Yeah, that was another thing I was going to work on, is that there's no hitboxes for the union objects. Still slightly sick. Oh, Rust. Oh, I love Rust. So 15 of my 16 programming years of experience are using Lua, which is kind of like Python. It's a scripting language. And I'm finally freed from the weakly typed beast. And now I have strong, dependable types in my code. Finally. Years of being a caged animal. Come on. Come on. Yeah. Ah! What? What? Bro. Clipping through the walls. What is going on? Okay. Okay, it still thinks I'm in the zone. Okay, it's pushing me into the wall. You have boosters now? They've been there for a long time. They were just not interpreted by the map changer. This is bugged. This is straight up bugged. I'm gonna fall in the thing. Oh, I failed to fall in the thing. Come on. All right. Okay, it fixed it. Oh my god, bro. Nope. Yeah, so this is a booster on the ground right here. Every time you jump on it. Ah! Whoa, I didn't make that. Choosing the tools you want to use in web programming is the hardest part. I wouldn't know. I made a website yesterday using AI, and I had no idea what I was doing. But it needed to get done, and now it's done. And now I can get back to the programming that I want to do. Oh, you stop. Oh. I made it. Oh. Hell yeah. Oh, gaming. Okay. Oh. Oh yeah, I still don't have cylinders. Oh. I'm trying to work on the physics to make the physics work. But it's super hard because the physics is super complicated. I made my own physics system, physics engine, I guess, if you want to call it that. It's a single body physics system. So it's like not complicated in that way, but it's complicated in other ways. It's using like fixed point arithmetic and a widening multiplication where the numbers get more precise every time you do a multiplication operation, which I've never seen anything do that before. So it's a completely new way of doing math. I want to make the physics like really precise. And it works, which is beyond my wildest dreams. I thought it would just be like slow, and it is slow. There's cases where it like comes to a crawl, but usually it's doing nothing because you're in the air, so it's kind of fine. Stonewalling. You can't just peer over their shoulder. Yeah, you gotta find something that works, modify it, get your hands dirty, make edits. Like, code is meant to be read by humans, right? So you should be able to like read along and make some sort of prediction, like if I change this for loop to go one extra loop, it should go one extra loop. You should be able to make predictions at the very least about what changes would do. I think guessing and checking is making a prediction is like a good way to make sure your brain is training itself, because it operates on predicting the world around you. And so when you make that prediction and then you see whether you were right or wrong, you get that reinforcement. Whether it's right or wrong, it's always valuable. testing on new features. Cool. Ooh, dang. This game would go viral. It's definitely good as like background footage, but it's extremely hard. Like doing this, I have been playing this game for 10 years. So it looks easy when I do it, but it is actually not easy. This is a very precise movement. Look at this. I can show you my mouse. I'm doing all the movements. All the robotic movement is just straight up my arm. So while it can be fun to watch for a bit, it's kind of too hard to be anything more than a niche pastime activity. So here's another physics bug. You just fall through the ground. Wonderful. Great. Is there any progress on that Monster Jam bug? I started doing something else. I think I actually no, there was progress. I think this is the bug right here. So it goes all the way down to the genesis of the map object. So the face crawler algorithm was doing a mesh query for which faces are on the Minkowski edge, and then that algorithm was returning an edge that it shouldn't have returned because the precision of the like math was allowing a very small number to pass the check because the faces don't exactly match the vertices on the mesh. I think it drills all the way down. So it's like when the valve meshes are calculated from the faces, and then the Roblox meshes are just always like boxes. So what's going on is it's doing a matrix determinant to calculate the three plane intersection. Okay, there's 1, 2, 3. The intersection of three planes to get the intersection point, and then that is now a ratio of a triple precision number and another triple precision number. So it's a fraction, but then it truncates it into a single precision number that's not a fraction to get the vertex point. And that's just slightly off from where it was calculated that it's supposed to be. And that's enough to foil the physics algorithm. This is still a hypothesis at this point. I don't actually know if this is the problem. I just got to hear what's happening. I don't know. I have no idea what's going on. I'm trying to explain it, but it's extraordinarily complicated. All right, I'm just going to call it unwrap here, and we can call it a day. Probably is fine. What would happen is if there's two faces that are not quite parallel, and it tries to calculate the point of intersection, it's going to be like way up here. So if they're like really close to not being parallel, then the point will be like possibly out of the range of the fixed point precision. And that's what this operation does, is it checks if it's in the range of the fixed point precision when it's narrowing the precision. So it's like calculating a number and then narrowing the precision and checking to see if it's too big or too small. And so this just goes like, all right, I don't care if it's too big or too small. Just panic if it's too big or too small. So I'm just going to do that. It's probably fine. It probably isn't like that. Oi, 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 oi. Okay, so that is fix, brush, bruh, bruh. Uh-oh. Export. Okay, this song gets bad at the end. It's a nice song. Yeah, it's good, but then they start moaning, so all right. We're just gonna move on. Okay, next problem. All right, so this is gonna be like, very catchy. Oh. Huh. Okay. This is all common. Should be fine, right? No way. Ugh. Okay, so this is who else is arrowing? Arrow. Everybody. Yay. Okay, so I think this is here as well. I'm gonna push this over. Okay, so then this guy, we're gonna go to this guy. Fix one, map T fix one. I think, oh, this is an array. Mat3 from calls. What is this? T. I think I have a. Oh, that's a freaking vector. Unwrap. Try from F32. What is this? Matrix 3 Roblox types. Ah. Okay, I think this is a narrow unwrap type business. So it'll just big panic if it has any problem. Oh my goodness. Okay, what is this? Divide. Divide by size. So that's a fixed 1. It could be nearly 0. Probably it's not. But we don't know that. Okay, this seems like another narrow unwrap. Give me that comma. Let's go. Okay, next. It's just copied? Okay, I don't care. Okay. RBX loader. Implement precise width conversion. No way. What's the difference between fixed 1 and narrow 1? So this entire thing is being more precise about the different ways to convert between fixed point precision widths. So there is there's 2 ways to make a wide number into a narrow number. You can truncate it, cut off the bits, and that's like wrapping the number. It's like modulo 4 billion or whatever you're doing. So I call it wrap. Or you can clamp it, where if it's outside the range, it just becomes the maximum or minimum value. Cool. Those are different ways of doing the same thing. Previously, it was just called fix, and it would just change the precision by wrapping, but it didn't express that in any way. And then you could also directly grab the error. So if it's a narrowing error, you could do try into, and it would give you an error if you're outside the range, and then you could decide what to do instead of just implicitly clamping or like some other implicit behavior. So these are 3 different ways to narrow the precision of a fixed point number. But then there's only one way to widen the precision, and that's just called widen. You just add more bits, and there's no problems. So previously that was also called fix. So you didn't know if it was getting wider or narrower. It was just fix. So I had one size fits all for all of these different semantics. And I wrote this code a long time ago, but I never implemented it because I had just implemented the fixed point into the game, and this would be the whole work again, and I wasn't confident that it would all work. So so now I'm going through and choosing specifically the way that I want to convert at every point that I used to call fix. It now becomes narrow, widen, clamp, or whatever precise definition I want for that specific conversion, which is very cool. Cool beans. Cool. I have. Okay, so if you transform a point, that's probably a narrow unwrap, because if that's a big problem if it goes outside. Oh, actually I could error, but oh well. That's a problem if it goes outside. I don't want to implicitly clamp or implicitly wrap. I want to die instantly if it's a problem. press fix to die instantly. Okay, so then now we're on to the engine. Did I actually commit that? Yes, okay. Oh, yeah. All right, so this is called fix. So when you're running the game, probably you don't really care. So this is, I'm going to change this to clamp. And it's just going to clamp it. Even though that's not really, that's sort of a silent failure. You're playing the game, you don't care. It'll like look wrong, but you don't want the game to crash. Uh-oh. Surely. Yeah. Oh boy. Many error. Yeah, so all of this, I have to go through every single case again that I went through. Oops, that's the wrong camera. When I first implemented this. And so I didn't want to do it again at the time. Okay, so why is this going fixed 4? Couldn't we do not that? That's a fixed 1. Oh. Why wouldn't we do a 2 here? Huh? A 2. Huh? Why did it do that? Oh. What is N? Oh my god. I see. It was not 2. It was 5. And I didn't have a 5. But I didn't know that because it was so imprecise. So probably clamp would be the closest to correct behavior. Correct behavior would actually be throwing an error, but this function is supposed to be infallible, so yeah. Look at another N4. So complicated. So I just don't want to like actually clamp is going to be way slower. That's going to be like way slower. Oh boy. Golly. I did not expect this bug to be a precision bug. This bug as in the Monster Dam bug. Oh my. So what if how is n why is n 3 in this case? Hmm. Is that directly implemented? I guess it is. Oh, output. I see. All right. Okay, so I think I'm gonna change these clamps to wrap, because that's the fastest. So it'll be like crazy wrong and kill you, but it's not supposed to. It like you would have to be at the edge of the world and touching a model that's the size of the entire fixed point range, etc., etc. Oh my. Face. Face hash is stable, and there are no flush faces. Why don't we go with narrow unwrap? Because this is like map loading. Shut up. What is going on here? Fix one vert transform. Right. Yeah, so it's not supposed to go outside the range of possible values, and it's like called a lot. So we're gonna go with wrap there. Why don't I document that in face crawler as well? Mm. 1 1, so this is 2 4, and then is 2, so it's 4 divided by 2. I don't know. Probably fine, right? I'm gonna have to do this all again when we have const generics. Ay, ay, ay. I like how it knows which function I want. based on the return type. That's nice. Okay, what the hell going on through here? N. Okay, this is widen. It doesn't know what I want. Oh. One. Oh, yeah. N. Surely. Cool. So you aren't allowed to widen to itself. So like if you have a 2, you can't just call widen 2. That's a compiler error, which I think is excellent. This is very silly, but what are you gonna do? Oh, this is a stupid algorithm. There's got to be a better way to do this. Vert. Yeah. So what is this? God. I think I need to call this wrap for speed here as well. Vert edges. Is this generic? No. Very silly. Oh, hold up. Well, can I do this? Damn. Unlucky. What is that? Oh. Interesting. Okay, next. Width length divided by Excel. So width length should be fine to wrap, but divide by Excel would need a clamp. Because it might be close to 0 and then overflow. Whereas with length, this will like be approximately the size of this value. On all axes. Surely I can narrow unwrap here, because that's the most loud version of clamp. And this is only called like once when the game loads. Okay, so this is a vector that's near 1. This is also a vector near 1. So these are fine to wrap. They should not be very far from 1. V. So this is... What the hell function is this? Generate models. Sure, we'll do narrow. And then this is runtime contact normal. Uh-oh. Wait. Normalize. Minkowski mesh face ND contact normal. I think I looked at this before. Ugh. Constrain acceleration. Okay, so it's right. Okay, so this is external push solve. This is doing push solve stuff. It's not super important. So it's probably fine to keep it like that. This is a fixed 3. It shouldn't be very big. Const. Teleport to spawn, we can just clamp that. That's not gonna happen very often. There is an error path actually, but working with the errors is not very nice. Yeah. Where is it? There it is. Plasticity fix 1. So elasticity is between 0 and 1. So this should be fine to wrap. It goes up to exactly 1. Width length 1. Huh. Yeah, that wraps easy. Uh-oh. Solve divide. So solve divide. So what if the direction is infinity? What does that mean? That means it's nearly 0. Or nearly... collinear? So this one is for sure collinear, and then this one is like identically. And then like if it's too big, gosh, I don't have a good way to grab the error out of this. Oh. It's not nice. I don't have a nice math library. La. Seems like it should pretty much always be narrow and return an error. And like I'm basically just pretending that errors don't exist. It's not very rusty, I must say. I'm kind of like approaching this where if it's not a problem yet, I don't care. So let's keep going. Fix. Yeah, realistically, this should narrow. Narrow. It should look like this. Narrow. Okay. Question mark. But this is a vector of results rather than a result of vector. So the problem is it's too hard to do that with an array. To like collect an array of result into a result of an array. So silly. The whole thing is really silly. I'll just wrap for speed. Because like this runs a lot. Oh. Okay, next errors. Oh, we're done. physics. Sec. Lots of changes. Okay, what happens? Did I break it? Oh yeah, this is a new release. Oh, it's freaking done. 15 seconds, damn. You good? No panicking? Yeah, it's pretty rare to exceed the precision of the smallest precision. Exceed the range. The range is massive. It's negative 2 billion to 2 billion, and then there's 4 billion subdivisions for every unit. So it's a 64-bit number, and then it only gets bigger from there, more precise. Cool. All right, it's not too laggy through the area. More laggy than it already was. Neat. It's so ridiculous how much math I'm doing. I hope it gets cleaner over time, and I can like have some ideas about how to do it really good and like actually make it better, so it's not just fix forever. I guess I did do that just now. It's like slightly more expressive. Need lots and lots of iteration. Buh. I wonder if I can like skate off the side of that to surf to get up there. I think it would be 30% more productive if you played less. I wouldn't know all the problems though. Like, all right, I wrote the code. I'm testing right now. You know, I just made a major refactor of the entire game. I changed 289 lines of code, and it's just like, yep, works. That's Rust for you. All right. So I'm gonna publish new versions, I think, of these libraries, or at least market. I tested your game on Roblox. Damn, you're a tester too? All right, let's see. My test some more. So fix. This guy is now different, and this guy is also different. This is only an extension. Okay. Mm, Common. Oh, okay. What? Non-primitive cast. Since when? Hall? What? I need to publish it? Okay. It's okay. Oh. I see. Okay, I did it wrong. God damn. Is it gonna stop trolling me? I feel like it's trolling me. That was a crazy troll. Okay. Does it do the log file as well? Cool. All right. So oh. Right. Um I guess I can. Um Okay, so these guys should go underneath. let's go. And then that should be the same except for the versioning. And then is he gonna troll me more? Is this trolling? No. Okay, cool. So I should be able to just publish, and we're good to go. There we go. Okay. Surely. Sick. All right. Nice. Okay, so now it should work. Oh, cool. Cool. Okay, so I think that's good. And then this should download the 2 new things. I guess already did. And it should work. Oof. Cool. It works. Cool. 10 ahead. I press the button. Do it. Okay, well, I am pleased with that. This branch is no longer needed. Whew. I wonder if this will cleanly go up. Probably not. Oh, wow. Okay. So probably that had nothing to do with the bug. And it just still happens the same way. Change everything except fix nothing. Yep. Just being more precise in the expression of precision conversion, width conversion, which is also precision. Crazy. Oh, very nice. I always go to try to fix the physics bugs and then like procrastinate by doing something that I was putting off. So I'm like peeling back the layers of procrastination. But that's like weaponizable. If you have something that you mega procrastinate, you can accomplish things that you're normal procrastinating. Hell yeah. Why did you not code correct from the start? How old is that comment? Because I wasn't forced to. I'll take any shortcuts I can. And so I choose Rust because it lets me take fewer shortcuts. So even though I try my best to take shortcuts, what the hell? I am forced to write competent code, which I want. I want like the best possible code. But then I don't actually do it unless I'm forced to. It's a dichotomy. The duality of man. Does it still say -0? It does. So look at the size of this number. Look at the size of this number. It's basically 0. Fix fell 7. Subscribe to Prime. Thank you. And I think that comes from what I was talking about earlier, where why don't I write it down on this branch? Physics bug 2 originates from vertices being imprecise? Question mark? Huh? Okay, so one way to solve this is to truncate the precision. So it rounds to 0, and then it evaluates as 0, which would honestly make the physics way faster. Okay, I added this, but I didn't actually use it. Ah, crap. Is the ailment improving? I do believe. I feel less sick, so it's no. That's noise. Rebase. Come on, skip. It should be like identical. Yeah. Okay, so what was I thinking? I guess I'll do it on this branch and then move it later. Let's say so it's in the physics algorithm. When it does this guy, so this says 8, but we can just not do that. So I think this D value is very close to 0, but because my math is exact and it never throws away precision, it's like, technically it's not 0, but then that's problematic because the meshes are approximate. So it's doing exact calculations on approximate meshes. Nor. So we need the epsilon, but I'm going to implement it with a truncation. Or maybe clamp is better. Dot product. Fixed 3. So let's do clamp. Let's see what happens. What do you want? So this guy now becomes 264, right? And that is quite a bit less insane for the calculations. This was one of the most run ragged areas of calculation. Probably that would reduce the lag to some extent. XD? Wait. This is edge vert. There's also vert edge here. What about the denominator? It doesn't super matter. It's just finding the best one. Like, it's not like it's gonna... I don't know. Let's run it. The B-Hop gods, are you watching? Sigh. Oh look. Okay, so there's the bits. So now it says -2. So it's within the ability of the lowest precision to represent at a value that's not 0. So I was kind of expecting it to round to 0. But I guess that makes sense. Ratio bits 4. It's 2 squared. This is like 1/1000th of a unit. And then the denominator. Outrageously precise. Let me honestly, let's see if it's faster. I'm curious. Perhaps not. I think there's a bug. Where did the map go? Oh. The strafing isn't working. Why would that happen? What? That should not affect strafing. Have you making changes to troubleshoot the physics bugs? Not really. I intended to, but I kind of was just handling other stuff that. Okay, so there's some kind of other issue going on here. Huh. Yeah, that's what I thought. Okay, what the hell did I do? Is 0. But that's just a physics calculation. New at position. Oh, there it is. I literally disabled strafing. Okay. Well, that explains it. Because I disabled it because it was irritating during the integration test. All right. Bop. All right, let's build this version with strafing. So, all right, I'm gonna bop this onto master branch. Come on, bro. Just do it, okay? Okay, so this is what I wanted. Hmm. All right, so let's jump around. See if I can evince new bugs. I wanted to see if this is slower, or faster, rather. Boom. Oh, come on. Okay. Let's swap the positions here. Surely that's the problem, right? That's why my beehuffing sucks. What's up with the window? Why does it always have a new line? Oh. Gah. Oh, working on the game mechanics is so much easier than trying to fix physics bugs. It's crazy hard. All right, here we go. What? Do we get frame drops still? Oh, yeah. No, there's not really a fix. Yeah, no, it's just the same. Actually, what about the integration testing? What if I run the determinism speed run stuff? Go! So previously it was at 37,000 ticks per second. And like run-to-run variance is about 1,000. So if we see like 40,000, that's a measurable difference. Always looking for ways to speed up the tick per second. 38,000. Yeah, no, that's run-to-run variance. Oh, so this is unfortunate. Because, like, it's looking like I am going to need a epsilon. And, like, my entire idea here was to never use epsilons. I wonder what 21-bit faces would look like. What is that? 5 bits of angles. So that's like 32 units. But it still doesn't solve the problem because the vertices are still ratios. Maybe that's it then. Because, like, if you do normals from vertices, you don't get ratios. But if you do vertices from normals, you do get ratios. Right? Because to get a normal, you just do B minus A, C minus A, cross product. And that's it. There's no need to normalize. Maybe that's the play. Maybe I generate the normals from the vertices. I guess that's actually a decider. So I was sort of undecided previously. But that's basically it. This could be it. So if I limit the precision of the vertices to 32 subdivisions per unit, then the number of possible face normals is limited to a single the like lowest version of fixed point precision. 32, is that right? 30, 32, 30, 10 bits, 10 bits. Actually, it can do 10 bits, right? 10 bits. So I'd have to recalculate the normals from the vertices. Do I do that? What go on up here? Mesh query. Physics mesh. Where's the converter? There it is. Try from mesh. So vertices, faces. Yeah. Yeah, I'm calculating the face normals from the vertices. So if I truncate the precision of the vertices to 10 bits, then that expands to a maximum of 30 bits of precision when you do the cross product to find the normal. No, but there's also the transforms. Ouch. So, this is a problem at conversion time, kind of. $10 bits. One epsilon. I'm trying to not do epsilon. So I'm trying to make it so that the calculations will end up exact because the face normals never exceed the precision. So the vertices will happen to be 10 bits of precision. I think it might still work actually, even with the transforms. Maybe. 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 It might still work even with the transforms. Ooh. So we only have one. Okay, so this would be. Yeah. Let's give it a shot. I'll go to the BSP loader and truncate the precision at the origin of the bug. Just give it a gander. So this is a special operation. Const mask Can I do P64, please? Yay. Raw. Not. One. shift left, 10 bits, -1. So I'm masking off 10. No, I want 20 bits at the bottom. Masking off the last 20 bits. Oh, actually, I need 22. So this is... Oh, actually, I need to put this like this. 32 minus 20. Mask off the most precise 22 bits so that when face normals are calculated from the vertex bits, they never exceed 32 bits of precision. Period. No way. So I think I can just do this mask. Oh, it's a vector 3. God damn it. God damn it. Okay. Do I even have this op? Oh. Vector. Yeah. Oh my god, bruh. Okay, how do I... Can I... Do I have a vec3 splat? I want to splat! Oh my god, bro. Alright, do I map the mask? Screw it, that's the laziest way to do it. I don't remember how I did this. Alright. Surely. That is a very fancy bug fix. Surely. All right. So I actually can't just do it increasingly uglier at an exponential rate. Yeah. Okay, so how do I make it happen? How do I make it happen? Okay, I gotta convert the map. So I should be able to go like bruh, 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 bruh. Come on, bruh. Just take it, okay? What do you mean? It's not changed. You're trolling. Okay. It was a comment. I see. Okay. Bum. Okay. Fancy bug fix. No way. So now we go here and build it, but with the source compile feature, source convert feature. So then when I load it up, load up the Monster Jam, it will truncate the most precise bits, leaving only the integer bits and the first 10 fractional bits of the vertex positions. So it'll like round the vertex positions like a PS1, but with like a little bit more precision. Oh, you're dumb. Okay. Please stop. Please stop. Please stop. bhop bsp Monster Jam. Yeah. So it just converted everything, and there's missing models because reasons. And now if we go over to this spooky part that caused the bugs previously, and we touch it. All right, what do you think? Did I fix the bug or did I not fix the bug? Ah, gross. Ruin the moment. All right, I'm just going to do it. Damn, not fixed. Ruined. Okay. My fault for trying to be a streamer while I'm sick. So I expect that nothing changed. I expect that... So you can't really see any difference. You might... If you're like looking this close and I flip back and forth between before and after, you might be able to tell. It's truncated to thousandths of a Roblox unit. The vertex positions are truncated to thousandths of a Roblox unit. Wait. The top face has like how many vertices? 1, 2, 3, 4, 5. I don't know. I don't actually know if this is the problem. colliding with a face on your hitbox, interacting with your player hitbox. I don't understand the difference between the two things you said. Or how. Okay, so there is no difference. You're just asking how it works and providing an example. Yes, it's colliding. Like if I go like this, if I'm like moving in a non-falling straight down way. Oh, interesting. The side worked. Whoa, 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 whoa. Success case. So I'm averaging the vertex position. So 5 vertices does not a face make. I wonder if I need to always use triangles. So I have to. So the reason I didn't use only triangles and I had faces was because there's poor handling of the flush faces. So like if I close this, wait for it to crash. Mango Head is crashing, and then I run this. So if I'm standing here and there's a triangle diagonal halfway down here and I go like this, I'll fall through the ground because the that's one of the physics bugs that I listed. Oh, this is still running. Cool. Okay. Smooth transfer between flush Minkowski surfaces. So I need to do that anyway. The reason I didn't have triangles only is because this is a weakness. Maybe I should always use triangles. That also means I can do less allocation. I can improve the mesh packing, the mesh file format. I can use triangle strips. Triangle strips are twice as efficient as triangle lists. Or I guess 3 times as efficient in the limit. What is running? Oh. Damn. Oh, damn. Damn. That's a big rewrite. That's a file format change. But like I knew I wanted to change the file format, but I wait for these like decision makers, technical indicators where I could do it this way or that way, and like there's not really any reason to choose one or the other. But now I have a reason to use triangle strips and do triangles only instead of having polygonal faces. And then also, what's the other one? I don't know. I should probably write it down if I remember it. Gah. I'm gonna look up maximum area triangulation. And then I did. That is not what I'm looking for. Let's go. I don't have a camera angle for this. You know what I could do actually is I could just like go like this. Fragments are processed in quads. Really? That doesn't sound right. Whenever a polygon edge cuts through a 2x2 pixel layer, is that what they mean by quads? That quad will be processed twice, once for both of the polygons covering it. If the fragment shader is complex, oh, you know the fragment shader is complex in the new games. $16 pipe. Fan. Very bad way to do it. I'm doing it like this, but on the side. It's essentially the worst way to do it. Equilateral triangle in the center. And recursively add new triangles. I don't know if the scheme has a name. It's called max area. This might be like the origin of it. A greedy algorithm that in every step adds the triangle that would grab the largest possible area. That's pretty simple to implement. Ugh. I'm sure there are examples where you could beat such a strategy with another division scheme. I imagine there's not. Seems weird to like draw small polygons, but I think it's the best. Their performance looks like this. Holy. Then we're along the x-axis, the vertex count around the circle. The y-axis is frames per second. So this is fan, this is strip, max area. That is pretty drastic. Further adds the burden. Oof. 0, 200, 200. That's amazing. Comments. Ooh. Comments. For real. Nice analysis. Enter the code below. This guy made his own CAPTCHA. Max area on top. For real. You probably won't believe it, but I spent my whole day working on exactly such a translation. Checking your blog earlier. But they are not long and thin. Not nearly as much of a problem. Okay. This guy from 2009 might be onto something. Well, I went looking for this specifically. Well, this might be the origin of the information, but I heard this information. I believe it was on a channel called Threat Interactive. This guy, this like young looking guy is really passionate about how bad graphics are today. It's fun to watch. He hates it. He hates Unreal Engine and stuff. I'm like, yes, I hate Unreal Engine. And he mentioned this concept of max area, and that like describes it so well. I know that guy. Yeah, he's quite popular on YouTube. He's breaking into like normie recommendations, which is great. He's very professionally spoken and like assertive, and always believes what he's saying with 100%. Which like that's entertaining content. He sounds like an AI. He's got a script for the videos. He's like reading off the script. Write an essay. It's essay. Video essay. So now my brain is going into like hardware territory. So there's dedicated hardware, fixed function hardware for triangle lists and triangle strips. Can you do max area? Well, it's kind of recursive, so it's probably just, you could like construct it with several strips, it probably wouldn't be that good. It's probably just not worth it, and you just should use triangle lists. 2-minute papers. Who are we talking about? Threat Interactive. Unsubscribe from Digital Foundry. Look at this. The face. Oh my god. It's so serious. Unoptimized, overcomplicated, blurry, noisy, basic visuals. But he does an in-depth analysis of a frame of the game. It's like actual analysis and like opinions about what's going on with the gaming industry. This should be standard optimization. Hell yeah. Fun channel. I don't know why I checked this. There's so many comments. TAA, yeah. I'm not a fan of TAA either. I'm like very well aligned with everything that this guy says, which makes sense because I'm game developer side, engine developer side. I've seen what's inside. TAA pull request rejected. Wings. Oh, is it a game? $2014. God, that 2014 is more than 10 years ago. Good God. 2009 is ancient history. $2014 is like a couple years ago, right? And 2009, well, that's a couple more years ago. I explicitly triangulate. Auto triangulation. What the hell is Wings 3D? Is it 3D modeling? 3D modeling? Is this text? This isn't text. It is modeling. Cool. Okay. Well, this is cool. 2024. Holy. What? What do you mean, does this thing still work? Bruh. Your article got referenced. No way. Cool. So that's graphics optimized. What about physics optimized? Yeah, I definitely don't want to introduce more precision just to grab the face normals. So I think dividing the precision by 3 is a good idea. I don't know if this is actually the issue. Okay, okay, so how can I, okay, let me try triangulation. So this is, face. Okay, so this should be, so max area is a technique for graphics, but the physics doesn't really care how the triangulation is done. It'll fail regardless. But I want it to work. I want to fix it regardless. But I think that the collision might get fixed if I do it. So I'm going to drop this here, and then I'm going to do fancy bug fix. So I'm going to keep the masked vertices. So the vertices are 10 bits of precision, and then when you do... Wait. Oh, no, it could be 16, actually. Because you do one cross product. What am I smoking? Oh my god, that's so much better than a determinant. Oh my god. Okay, so it's way better. Okay, no wonder I chose this. Okay. It doesn't mean to... Okay. 16 bits. So that the remaining 16... Alright, so 32 minus 16, that's 16. So mask off. Yeah, okay. Dummy. Okay. It's a single cross product. It's not a frickin' triple cross product. TAA and DLSS. I would rather step on glass. Holy. Okay, wait. If I gotta test it. I gotta test it. Okay, let's go do it. Actually, you know what? Why don't we do Rust REPL? Go away. Let's see. Why? What do you mean example? Cringe. All right, let's go to a different one. Ew. Okay, never mind. I'll just use my own. Here. Okay, so now. Oh my goodness, go away. Really? Okay. Okay. Okay, so this is an example of how traits work. Cool. Okay, so it's taken so long that I've forgotten what I'm doing. Okay, so we do mask equals like this, and then we do negative I32 should be good. Yeah, we got a bunch of bits. Look at all those bits. Okay. And then oh my god, bro. Out of range. god, bro. Okay. Looks good. I think it'll work. What the hell? Yeah. So a negative number remains negative, and a positive number remains positive. Okay, that's what I wanted to say. Okay, that was freaking hard to do. I just wanted to like go type that, right? And I didn't want to open the project. I expected some website to exist. Okay. Mm. So that is cool. I did that. So I know for sure that it's not going to misbehave. Honestly, I kind of want to like make the meshes less precise to begin with as well, because the precision gets so out of hand. Like you don't actually need that much precision. Oh my god, bro. Okay, so but I'll save that for later. Okay, what I'm going to try to do is do the max area triangulation. So really I could be doing any triangulation to test this. Okay, come on, keep the motivation. Keep it. Oh, it's fading away. So it's gonna go right here. So you got faces. Ooh, physics groups. What the scallop? This is okay. Polys. So this is poly vertices. So this is where it would happen. Submesh face ID. Ooh. I don't remember why that's important. This is goated. So look at this. The face normal doubles the precision, but I'm averaging. Ooh. Hmm. Mm. Mm. Triangulation. I could actually detect it. And do both, but oof. What? That's bad. This is this is awful code. Okay, so I want to understand this issue. The same face is not allowed to be in multiple polygon groups. Why? Gosh, I'm running dry on motivation here. I'm gonna just have to roll every day and get lucky by being smart one day. Sometimes I'm smart. It's really nice to sometimes be smart. But it is a bit irritating that it's not all the time. Oh. Okay, I'm getting it. The idea is the complete mesh. Imagine a donut. You got some polygons, and it's only the surface. But in order to create physics for a donut, you have to split it up into convex submeshes. So the submeshes are those convex submeshes. But the submeshes must be a complete convex surface, so they have to have planes in between, like on the inside of the donut that you're not supposed to ever be able to hit. So then, if the physics ever thinks it's going to hit one of the inside faces, it can check to see if it exists in the complete mesh and like not hit it, I guess, so that you can only touch the surface. Why do the faces have to be unique? So this breaks down when you have a donut because of this hashing the face. Why is it hashing the face? Crazy. Tunnel you get lag spikes on inside of a donut. It's a tube. The thing is, though, that's not a single object. That's a bunch of unique objects. So, but you could, in my physics system, it's supposed to support that. And the idea is that since there's behavior that happens on contact, such as a ladder, when you touch a ladder, you stick to it. What if the ladder goes like this and it's like a curved ladder? If you're climbing on the bottom of the ladder, you shouldn't go like and stop every time you like touch a new face of the same object. It shouldn't count as a new touch event. You should just still be touching the same object. It shouldn't activate the like sticky ladder. So it needs to know that it's the same object somehow. But it still needs to be able to do physics on arbitrary mesh shapes that are decomposed into convex submeshes. I never really fixed this up because it's doesn't really happen. Bro, there's like so many details. Game engine. I am boobed. It's been 4 hours, 45 minutes. Take a break, then come back. Doesn't do that Yeah, I haven't really discovered that yet. I did something today. I implemented my YouTube lag. Did Abyssers crash? No. The precision width conversion stuff. That's nice. I'm gonna write this down. So, to do max area triangulation. Wait, this is physics. It doesn't care. This is physics only. The triangulation should be done ahead of time. Never mind. Okay, actually, this doesn't belong here at all. So it has to go here. Oh. Vertex. Face. Oh, face list. Where's the thing that does the thing? Planes to faces. Faces. Faces to mesh. Huh? Faces to mesh. Oh my goodness. Polygon list. Oi. Face. It'll be right here. Vertex position. Dude. I think I can write this from memory. Oh, actually it's here. Oh my god. Okay. So instead of collect, it's this. And then you go like, okay, it's like, surely. Okay, I gotta cheat. Never mind. I'm not ready yet for memory. ICBA. Oh, come on. Graphics? It exists here. I know it. Oi, give me that. Yoink. Unwrap. Oh. So this is flat map then. true, I guess. Did I do it? Okay, so this is triangle fan, the opposite of what I was gonna do, but I just want to see if it works. Okay, so let's just see if it works. So now what's going on is it only makes triangles instead of faces that consist of more than 3 vertices. And how does that help? Well, now you can have a face that's slightly folded. So like you can imagine that like it's slightly off, because like if you have a cube that's like this, the vertices are aliased to world space coordinates. Well, no, not really. They're aliased to mesh space coordinates, and then there's a world space transformation that increases the precision in a ridiculous way, but they're aliased in mesh space, and that can still be problematic, especially on that one part that we saw that had 5 vertices for one face. One of them is like in the middle of the face, and so it would like subtly be not exactly on the face. So what we should see is that it works. I have no idea. I just opened this for no reason. Okay, that's a sniff 'em. Wait, I never actually did it? You're a dummy. Shut. BSP. Okay. Please work. That would be very kind. It might just crash or something. Like I might have implemented it incorrectly or something. Okay, so... Oh! 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 Come on, come on. No. Wait, what am I jumping on? Is it like better? What am I jumping on? Is it a different bug? Did I fix one bug and there's another bug that causes the same problem? Because like it looks like it's a little tiny bit less consistent. I swear to God that didn't happen before. I don't know though. Let's check it out. Let's check it out. So I close this one. If I go to the Sniff'em version, that has the old polygon setup. Where did it go? And what that means is, help, let me out. It has, depending on the elevation, no, it would be position related only. So I'm over here. Okay, so it did happen over here. I was like over here though. Oh. Doesn't it seem like less consistent? Like it's more consistently broken. This testing is so scuffed. Oh my God, gross. I'll be right back. Okay, so this is the old one. And then this is the new one. And if I go over here, it's totally better. It's totally changed. That is totally changed. So it still has the same bug, but it's different. That's good. Yeah, that's super good. I have touched the problem. That is amazing in these kinds of situations where it's unclear what the problem even is. Oh, so I guess another thing I can try. Let's try generating a map file and outputting it to a strange location. So let's do map tool, cargo build release with 1L. So the map tool will now generate a slightly different file. Do breakpoints work? Zed doesn't have a debugger. And I've never actually used one before either. I always just print. Starting to think maybe I should try. Bruh. One bad thing about the monorepo is I never touch the version numbers anymore. My version numbers never really increment. So I've been trying to look for an auto bumper that I can just like press a button and it'll be like this code has changed, bump, this code has changed, bump, this code has changed, bump, and like automatically bump the version numbers according to Semver. And then my version numbers will like skyrocket. Anyways, so what's going on? So there is that one right here. So there's this VPKs, source to sniff, output folder, bhop BSP, bhop monster jam, and then the output folder. Actually, I don't want to replace the one that's already there. I want to make a new bespoke version. So let's put it into strafe integration testing. Just there is fine. Oh, I know what the problem is. It's reading files from this hard drive, the SSD. All right. So now there's another version of the map. So now let's go to the blue over there. It's tester, and then the map. So let's load that version of the map. Oh, it's here. Okay, so now we have the integration test. So now we can load the file called Monster Jam. Just right there. And then yeah. All right, that'll go. I'll be right back. What do we expect? It might work. I don't know. All right, let me guess. It didn't work. Whoa. Whoa. Did it actually work? Look at this. This is the old one. Miss. And then the new one. Hit. So look, this says face vert. And then the normals aren't 0. Did I actually find one of the sinful 7 bugs? I mean, it still happened in a slightly different position. And you know what's hilarious is I bet that it's a completely unrelated bug that causes the same problem. Just by moving my position slightly and falling somewhere else, it just hits a different edge case. I bet. I bet. But this is progress. I'm blown away. I don't know if I should be surprised because like it depends on the specific setup of the vertices, and I'm changing the way I'm changing them ever so slightly, but like is it always because of this? Hmm. 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 I think the plan to truncate the precision of the generated meshes and then also use that in the type system is a good plan because it like there's multiple benefits here. It makes it so that the normal vectors are always within the means of the fixed point to represent it at the lowest precision. And it also means that the growth of the precision as the calculation proceeds can be significantly reduced. And like having the precision, the maximum precision of the calculation makes it run 4 times faster. It's quadratic complexity. So that's good in multiple ways. But that's a big rewrite. And I've sort of been humming and hawing on it. I don't think I'm going to do it now. Because that would be a mesh format change. Or maybe I will do it now. Because, like, it would be good to do. I'm going to write it down. I'm going to write it down. Mesh format change. Vertices half precision. Triangle lists only. Yeah, that's the mesh format change. That's a summary. I guess I should write down the reasons. Half precision. Because face normals fit in full precision and reduces maximum precision. And then the triangle lists only is face exact face normals. Cool. Okay. Good job, me. Pat on the back. I wrote it down. Some guy some other time will handle it, probably me. As in nobody else but me. This is insane. 7 bugs. I have 7 bugs. And I've worked on this one bug for 3 days now. Is it Thursday? Oh my God. But I have a year. So my goal is to fix these by the end of the year. And so I'm kind of starting early. Get ahead of it, which is unheard of. I really am tired of falling through the ground. This one will be easy, surely. Oh, this actually might be the same bug. There's a chance. Oh, right, but I was saying like the bug I'm working on might be 2 bugs. It might be it. Great. I saw it. Okay. Okay, I'm gonna build the debug version here. I guess I don't need feature source. And then I'm gonna load the Beyond Monster Jam. How did it know? And then print the position evince the bug, edit the unit test, see what the other case of the bug happening is. Let's do that right now. Okay, so this is the fixed version of Monster Jam. What, I just clipped through the riff easy. It's, oh, I should write no clip. That's right. Okay, so now oh, it's printing a bunch of stuff. Press P. Oh, that didn't work. Oh, it's right here. Give me that. Oh, no, it's not. It's right here. No, it's right here. I may have a bit of a mess on my hands. Print body position. Whoa. Debug graphics. Right. Do I need any of this? No. No. Alright, let's go to the... I don't actually need source feature. I can do it. Alright, load the map. Alright, now we have debug view. Debug view. Debug. Oh. Okay, so we're looking at model 2263 this time. It is not 2262. We already did that one. Okay, so we print out the position, then we fall through the ground, and we're standing on the part. Ah! Okay, so that didn't work. Well, let's try it. Oh, try again. Oh, oh, interesting. Let's print that position. Fall through. Way. Okay, so that doesn't work. So let's go over here. Print the position, fall down. I was just walking on it. Holy smokes. Okay. Well then what about here? Print the position, fall. Print the position, fall. It's freaking working! Why doesn't it do the thing where it didn't work? Print the position, fall. I can't make the bug happen anymore. Whoa. Dude, I can't make the bug happen anymore. So I can still fall through it, but not consistently. So the whole point of that was I could consistently evince the bug. I love that word. Events is such a freaking cool word. I sound so cool saying that word. What the hell is that? Can I events here? Earl? No. If I go like this, it might work. Oh, that's the walking bug. Oh. Wait. Okay, hold on. Ooh, Damn. It doesn't happen. I actually think I actually fixed the bug. That's a different bug. Wow. It's so complicated. Oh! Goddamn. Oh, is that an infinite loop? No, it's a divide by zero. Okay. Now, what do you suppose that is? Honestly, I can die happy. Meaning I can end the stream happy. This is good enough. I actually just straight up fixed one of the bugs. It'll take a while to like implement properly, and I'll have a mesh format, file format change. Wait, can I return an iterator? Can you return an iterator and flat map will like be trilling? Is that allowed? Doubt it. Function mutt. Escapes close your body. My bad. Oh, okay. Huh. I see. So it might have allowed it if I didn't have the mesh builder. God damn it. Okay. Silly. Allocate. Oh, yeah, allocate. It's just the builder, but yeah. It'll get better. Things will get better. I've discovered the root cause of the issue. And like whatever happens next, not my problem. Until tomorrow. Wait. I'm building slightly non-convex shapes. This is crazy. I guessed this. That's really my superpower, honestly. Like all my life I've been great at that, where like I have just partial information and I make a guess that ends up being the final answer in like math homework and stuff. And the teachers hate that, right? You got to show your work. It's my personal genius. This is great. Good work. This is kind of like maintenance effort to like just like bring the code quality up a minor amount. Prevent my future self from making mistakes. Think carefully. Damn, that's so cool. This is so cool. I'm just going to have to throw time at this. Now what? God, I could just like teleport to the future and just like be hop on the final version of this game. Without looking at the code and just get my times as I'm making the game. I can just play the game and it's all worth it. I'm making the game because I want to play the game. That's why I'm making it. Dude, it's totally gonna hit the edge case when you're walking across the surface. I'm done, man. Damn. Okay, incredible. Summarizing my thinking. Not only can I reference it later, but it also helps me like ingest the knowledge. So remember. Okay. I'm freaking done. That was very mentally draining. What can I eat? I got cheese. Yeah, I got cheese. And bread. I can put the cheese on the bread. The bread already has cheese, but you know what's better than bread with cheese? Bread with double cheese. So I'm winning over here. Disk space available 3 gigabytes. Wait a second. Is that real? Oh. I better end the stream fast. Oh my god. Okay. I'm running out of disk space apparently. All right. I'll be back tomorrow and do more work on cool stuff. So cool. Yeah. These bugs, these physics bugs. Goodbye.